So CMH has a number of different sub-projects. One of the big things that we're trying to understand is when the spill actually happened a mile deep, what are the chemistry and physics that influence that huge plume of oil coming out of the wellhead? And it's really, really important that we understand this, because there's a big contention about whether or not the deep plumes of dispersed oil were due to the real huge burst out of this gas-infused oil, almost like a spray can, versus the use of the dispersants at the wellhead. And so that will influence how we actually approach the next spill. Do we use more large volumes of dispersants at the wellhead, or is much of this actually just being created by nature? And so we're trying to resolve that fundamental problem. The other major components that we have are in the field, we're sampling both the sediments and the fish. And with the CMH funding through GoMRI, we've been actually able to sample not only in the northern Gulf where the oil spill was, but actually completely around the Gulf. So we've been in the Texas oil fields, down in Campeche in Mexico, and in this past May we're in Cuba. Right? So we have a baseline of the complete Gulf of Mexico, which kind of is unheard of. And like I said, we're sampling both the sediments and the fish. We were the first group to go out there and actually find that there is a significant amount of that oil, even today, that's stranded on the bottom. And the mechanism, I mean, when you think about it, what part of oil actually doesn't float, right? And we all learned that in 6th grade, right? Well, as it happens, there's a complex cycle that actually had brought a very large amount of that oil, maybe between 4 and 10%, to the bottom. Right? And so once it's on the bottom, it doesn't weather like the oil does when it's near the surface, right? And so we now know that it's being systematically landfilled, as sediment drops out of the river and compacted. And so what we found is that, there's a pretty still toxic lens of oil in a very large place. And one of the reasons we understand this is we were able to go back to a very similar marine blowout that happened in 1979 in the Campeche region off Mexico. It's called the Ixtoc spill. So we went down there and took sediment cores all around that, and we could find the Ixtoc oil buried under about 6 centimeters of sediment. So it's a very analogous situation that not all oil floats, right? And so that was a huge discovery for us. Right? Well, we have a lot of practical results, not only for understanding the Gulf as a being, how does the Gulf work as opposed to these individual places of the Gulf. And so what we're trying to understand is what we call the connectivity of the Gulf. That, for example, a red snapper off of Alabama, how is it related to red snapper that we found, all the way from the Florida Keys right around to Campeche, right? And so we're trying to understand the mechanisms that allow those ecosystems to interconnect. And so, and that's important because if you have a spill that has some catastrophic effect, what's the ability of the Gulf to repopulate these areas, and understanding the movement of the eggs and larvae that drift into water, and actually the movement of the adults to understand how the Gulf might heal itself is one of the major practical results. One of the other practical results is this notion of, should we be using dispersants at the wellhead or not? And it's a very active and open debate. And one of the things that we've been able to do is simulate that spill in a laboratory in Germany, in Hamburg, Germany. We've got a miniature version of the spill that we can run with high pressure, and we can get up to a mile and a half deep with low temperatures, 4.5 centigrade, like the spill, using dispersants and not. And we can actually figure out from that miniature, deep water spill, whether or not it's a good idea to put dispersants on them. I think a lot of our results has absolutely applicable to the response and also the recovery of the Gulf from the next spill. One of the things that we've been trying to understand is how successful were those fishery closures? The fishery closures kept expanding in size as the oil spread out over the surface, right? And so people were monitoring oil at the surface and kept expanding the boundaries of the closure. The point being trying to protect the public from tainted seafood, right? So one of the things that we found with this spill is not only could you observe it from satellites and aircraft, but we also know now that a lot of that oil stayed subsurface and it went different places. So the question is, how successful, just using surface, oil expression are you in protecting the public from that? And so now we know that we need to run a 4-dimensional model, where you got X and Y, the horizontal and vertical, but also the depth part over time. And so generally we're successful, but the next time we really need to run these new models that we never had before. Well, obviously, we're eternally grateful to GoMRI for, getting this funding and also supporting the work. And this, from my point of view, this has probably been the most important project I've ever worked on. And it's really heartening to have an amount of funding where you can actually conceive of big science and not, these small, short duration grants that you can never develop technology and understand it at scales that we're talking about. And that's, from that point of view, it's not only personally rewarding for us as scientists, but also it's also been great to interact with the public and the communities on the Gulf. They understand that the Gulf is their home, that they want to protect it. They understand the importance of the balance between the environment and the economy. And we're here, not to get in the way, but actually to help society better balance the economic decisions with the healthy Gulf concept. And so people should hopefully embrace science, and it's not just about punishing the guilty, it's about actually finding things out and making better decisions. And so I think from that point of view, it's been gratifying that some of the decisions that have been made actually are more and more based on the science that are coming out of GoMRI.